Welcome back to AI Academy's course on Python for data science. In our last lecture we have discussed about converting the columns to appropriate data type. We have also looked into the category data type in detail, and discussed which data type is appropriate for a particular variable. And in the last we have seen ways of handling the inconsistent data in the door column, since it has few entries such as number like string 5 in single or double quotes. And we also looked into the way to handle missing values in the door column. In this lecture, we are going to cover control structures and functions in Python. Next, we will cover about functions and what functions are all about. How do we define them in Python, and what exactly do we mean by a function? Let us start with the control structures in Python. So, the control structures are like decision makers of your code. It helps in controlling the flow of your code or how your program executes based on certain conditions or repeating action until a condition is met. So let's first break down when to use if, elif, or, for and while loop, and how they differ in their usage scenarios. The if and elif statements are used when you want to execute different blocks of code based on certain conditions. Think of them as the decision makers in your code. We use if statement to specify a condition. The code block under if statement runs only if that condition is true. It's like saying, hey, if this specific thing is true, then do the following. The elif statement comes in handy when you have multiple conditions to check sequentially. After an if statement, you can use one or more elif blocks to check additional conditions if the previous conditions were false. It's like saying, okay, if the first condition isn't true, then check this next one and do something different if it's true. Now coming to for and while loop, they help you repeat a block of code multiple times, but they're used in slightly different contexts. Like, for loop is typically used when you know in advance how many times you need to repeat the action. It's perfect for iterating over elements of a collection, like items in a list or characters in a string, and performing an operation with each of them. And the while loop is used when you want to continue looping as long as a condition is true, but you're not sure how many times you'll need the loop. The condition is checked before executing the loop each time, which means the loop might not even run if the condition is initially false. Let us now explore how the if-else family of constructs works in Python, using a practical example. We'll start with the basic if statement. Imagine you're writing a program to check if a number is positive. You would use something like if statement that checks the condition, number is 0. If this condition is true, it executes the print statement. If the condition is false, the code simply skips over that block. To handle the case where the number isn't positive, we can expand this with an else clause. This way, the program responds no matter what the value of a number is. But what if we want to specify more conditions? For instance, checking if a number is 0. We can use the if elif and else structure. In this setup, the if clause checks if the number is greater than 0. The elif checks another condition if the first one fails. The else clause covers all other conditions that are not caught by the previous clauses. Thus, using the if elif and else structure, you can handle multiple conditions sequentially, allowing for complex decision-making processes in your code. This flexibility is a powerful feature for handling different outcomes based on varying inputs. Let's now take a deep dive into how to use Python for managing and manipulating data, especially focusing on categorizing or binning of continuous variables. In this example, we'll be dealing with a dataset of cars data, primarily focusing on the price of these vehicles. Our task is to segment these prices into 3 distinct categories like low, medium, and high. This process can help simplify the data, making it easier to analyze and understand at a glance. To categorize car prices into bins, we need a place to store this information. We do this by adding a new column to our data frame for this categorical data. With this code we add a new column named price_class at the end of the data frame, initially filled with blank values. The command for same is df1.insert lock equals len df1.columns, column equals price underscore class, value equals blank. Now, let's use a combination of for loops and if-else statements to categorize each car's price. Here's how you can write this. For I in range, len, df1. Price equals df1.lock, I, price. If price less than or equal to 8,450. df1.lock, price underscore class, equals, low, to check price is in the low range. Elif price less than or equal to 11,950. df1.lock, price underscore class, equals, medium, if the price is in the medium range. Else. df1.lock, price underscore class, equals, high, if the price is in the high range. Here's a breakdown of what each part of this script does. The for loop iterates through each row in the data frame using an index variable I. And the if-else statements checks the price of each car and assigns a category based on its value. The logic here is straightforward. The cars priced at or below $8,450 are classified as low. And the prices that fall between $8,451 and $11,950 are marked as medium. And lastly, any price above $11,950 is considered high. Why do we need binning? The binning of continuous data into categories provides several benefits like simplification, which reduces the complexity of the data, making it easier to perform statistical analyses. Usability of simplified data can be more understandable and actionable for non-technical stakeholders. Visualization of categorized data is often more effective in visual representations, helping to highlight trends and outliers more clearly. Let us now visualize the results. After binning the data, you can easily create a bar chart with Matplotlib. So, first we import the Matplotlib library as PLT, then we count the number of cars in each category. And the syntax for the same is, category underscore counts equals df1, price underscore class, dot value underscore counts. This accesses the price underscore class column in the data frame. The column contains categorical data which represents the price classes, low, medium, and high, of cars, and the dot value underscore counts method is used to count the frequency of each unique value in the series. In this case, it counts how many times each price class appears in the price class column. And lastly, the values are stored in the category counts variable. Let us now move on to create a bar chart. In the above syntax category underscore counts dot plot, kind equals bar, the dot plot function is used for making various types of plots. The kind equals bar parameter specifies the type of plot to generate. And moving ahead. plt.xLabel, price class sets the label of the x-axis to price class. plt.ylabel, number of cars sets the label of the y-axis to number of cars. plt.title, distribution of car prices sets the title of the bar chart to distribution of car prices. Finally, plt.show, function is called to display the plot. When you run this line, Python renders the bar chart, which visually represents the distribution of car prices across the defined categories. This visualization will show you at a glance how many cars fall into each price category, offering a clear picture of the price distribution within your dataset. Similarly, the value underscore counts function counts the unique values in the price underscore class column of the data frame, and it returns a series object where the index labels are the unique values, like medium, low, high, and the corresponding values represent how many times each label occurs in the column. Let us now discuss about function. A function in Python is like a mini program within a program. It's a tool that you can use to perform a specific task, and you can use it over and over again throughout your code. You give it a name, and whenever you want to perform that task, you just use the name and the function does the work. It's handy because it helps keep your code organized, prevents you from having to write the same thing many times, and makes your code easier to manage and read. A function accepts input arguments and produces an output by executing commands within the function. Defining a function in Python involves using the def keyword, followed by a function name, a set of parentheses that include arguments, and a colon. The block of code following the colon is executed each time the function is called. Keep in mind that, when you define a function in Python, the body of the function must be indented. Typically, this indentation is 4 spaces or 1 tab. Every line of code that belongs to the function needs to be uniformly indented, starting right below the function definition. Let's take a deep dive into the practical use of Python functions with a hands-on example. In our dataset of cars where each car's age is listed in months. This data format will be more intuitive for understanding how old the cars actually are. People typically think in terms of years, not months. So, to make our dataset more user-friendly, we're going to convert the age from months to years using a Python function. Storing age data in months can provide accuracy, but it often lacks immediacy in comprehension. For instance, if you're told a car is 96 months old, you might need a moment to calculate that it's actually 8 years old. When browsing a dataset to make quick decisions or analyses, such conversions can become cumbersome. We first prepare to store the converted ages by adding a new column to our data frame called as age_converted. And the syntax for the same is df1 age_converted equals 0 to initialize the new column with zeros. Let us now move to defining the conversion function. We'll define a function named convertToYears that takes the age in months as input and returns the age in years. To make the data cleaner, we'll also round the result to 1 decimal place to avoid overly precise fractions of years that are hard to interpret. We will use the code def convertToYears, months. Years equals months/12. Return round, years, 1. This function divides the input by 12, since there are 12 months in a year, and rounds the result. It's a straightforward piece of logic, encapsulated in a function to make it reusable and easy to manage. Next, we will apply the function to the dataset where we'll update our new age_converted column with the result of the function by using command df1 age_converted equals df1 age.apply convertToYears. This command uses the .apply method provided by pandas, which allows us to apply a function across an entire column efficiently. And with the df1.head command we can see that age_converted column is updated with age in years. Let's expand our function to multiple input and multiple output by not just converting car ages but also calculate how many kilometers a car has been driven per month, assuming we also have odometer readings, in kilometers, in our dataset. We'll redefine our function to accept 2 arguments, age in months and total kilometers. It will return both the age in years and the average kilometers driven per month. We will redefine our function as def detailed_conversion with input arguments as months and total kilometers. We will convert month in years with syntax, round, months/12, 1. Then kilometer per month equals round, total_kilometers/months, 1, if months not equal 0 else 0. Return years and kilometer per month. And we'll apply the new function to data frame using syntax df1 age_converted df1 km per month equals zip asterisk df1.apply lambda row detailed_conversion row age row kilometers axis equals 1. In this version, we handle both conversions and calculations at once, making our dataset even more informative. This example showcases how a function can handle multiple types of computations, simplifying complex data processing tasks into manageable, reusable blocks of code. So, using Python functions allows us to efficiently handle data transformations and calculations in a clean, organized way. By encapsulating our logic within functions, we make our code more readable, maintainable, and scalable. Whether you're dealing with car ages or any other type of data, mastering functions will greatly enhance your ability to manipulate and understand your data. To summarize lecture, we've explored several key concepts and techniques in Python programming that are essential for data manipulation and analysis. We discussed how to define functions in Python using the def keyword, how to pass arguments, and how to return results. We applied functions to convert the age of cars from months to years in a dataset. This demonstrated how functions could simplify repetitive tasks and improve data readability. We have seen the advanced function usage by creating a more complex function that accepts multiple arguments and returns multiple outputs. This function not only converted age but also calculated kilometers run per month, showcasing how versatile functions can be in handling various data processing tasks within a single block of code. We revisited the basics of control structures like for loops and while loops to perform repetitive tasks, such as categorizing data or applying calculations iteratively across data sets. In the next lecture we will look into exploratory data analysis. We will delve deeper into the data and will examine the data by utilizing frequency tables and two-way tables. We'll explore how to derive joint, marginal, and conditional probabilities from these two-way tables, enhancing our understanding of the relationships between categorical variables. Additionally, we'll also look into the concept of correlation, broadening our analysis to include relationships between numerical variables in our dataset. We hope that you have found this course informative and interesting. Please hit the like button and subscribe to our channel for more informative Python for data science course. Your support means a lot and motivates us to create more educational resources for you. Stay tuned for the next lecture, where we'll continue our journey through Python's data science course. Thank you for watching and see you again and happy learning.